Hello again, Geometry A gang. Mr. Mandrell here again. Here's your supplementary video to go with Unit 2, Section 5 on proving theorems about triangles. Again, make sure you're watching and taking notes on the Edmentum tutorials, as it will show you more step-by-step instructions of how to do the proofs or fill in missing parts of the proofs, okay, and understanding what proofs are. It would take me a very long video to do that, so we're going to rely on Edmentum for that. But again, this is some supplementary information that I feel like will be key to understanding and unlocking those. Okay, so just three quick things here that I wanted to show you that I know will help a little bit. One is a very simple one, just a reminder here of something that you should already know, but just got to be able to remember to know how to use, and that is the interior angle sum of all triangles. We should know by now, it's something you learned early on, that the interior angles, or all three of the inside angles of a triangle, sum or add up to 180 degrees. Okay, in all triangles, it doesn't matter what kind or what type. And like, so specifically here, I just chose an isosceles triangle. All right, isosceles triangle, as you should know, has two congruent sides, and two congruent sides and then a base. Okay, so the tick mark here means that these two sides, side AB, okay, is congruent to side BC. Okay, excuse me, side AC. AB is congruent to AC. All right, which makes the base angles, angle ABC is congruent to angle ACB. Okay. So you might get a simple question that, if you might be given information like, if angle ABC is 40 degrees, what is angle BAC, or in other words, the top vertex point angle, right? Okay, well, that's pretty straightforward in the fact that, okay, we know that angle ABC is 40 degrees, right? How do we know how to find the top angle? Well, if this is 40 degrees, we know that, well, that looks bad. We know the base angles here, or ABC and ACB, are congruent based on the definition of an isosceles triangle. So if this one's 40, that means this one's also 40, right? Okay, so if they all add up to 180, we should be able to subtract the sum of these two angles, which 40 and 40 is 80. All right, and that gives us what's remaining. 180 minus 80 is 100 degrees. So angle BAC is equal to 100 degrees. All right, should be able to do that comfortably in all triangles. Okay, little review. All right, now on to something a little bit different here. Two things in particular. The first one is angle bisectors. So you need to be able to identify what an angle bisector is in a triangle. And all triangles can have angle bisectors. It's not like just any specific types of triangles. Okay. Basically the definition of an angle bisector, it is a line segment that bisects, or the word bisect basically means to cut in half. Okay. It is a line segment that cuts an angle in half. It's a line segment that cuts an angle into two equal halves. All right. So if I'm going to draw, we're going to show angle bisectors here from the top point, or the top angle, the vertex angle of the triangles here. So if I'm looking at angle A up here, or angle BAC in this triangle, all right, I've identified M down here because M is the midpoint of side BC. All right, an angle bisector will connect the vertex point of the angle you're working from. It is a line segment that will connect that point to the midpoint of the opposite side, or the side that's away from it, across from the triangle. All right, so again, an angle bisector is a line segment that connects the point from the angle, the vertex point from the angle you're bisecting, and it will connect to the midpoint of the side across from this angle, angle BAC. Okay? So, now, bisect means this, that it cut angle BAC into 2 perfect halves. So now we know that this angle here is congruent to this angle here. So, in other words, angle BAM is congruent to angle CAM. Now, I don't know what the measurements are because I don't have enough information to tell you what they are. I haven't given you any other angles. I don't know what kind of triangle this is, but I do know that they're congruent based on the fact that this is an angle bisector. And because of the fact that, and I know it's an angle bisector because of the fact that I've identified point M here as the midpoint. So really that's a given. So given point M is the midpoint of line segment or side BC. Okay. Okay. So once we identify or are given, they would have to tell you this, that point M is the midpoint of side BC, then you can state that line segment AM is an angle bisector. Okay, which means that it cuts these two, the big angle here, angle BAC, into 2 equal or congruent halves, angle BAM and angle CAM. Now, it doesn't mean that this comes down at a 90-degree angle. Okay, it doesn't mean that this is a perpendicular bisector to the other side over here, like we learned in the last unit what a perpendicular bisector is as far as line segments goes. It just means that it cuts that angle into 2 equal halves. All right. So if I identified the midpoint of another side, like side AM, or excuse me, side AB over here, let's say it was given that this is the midpoint, and we'll call this point S. Point S is the midpoint of AB. And again, I connect to this side here. As long as that's the midpoint, then that makes this an angle bisector, which means that these two angles are congruent. So angle ACS is congruent to angle BCS. Okay? All right. Now, over here, and the reason I wanted to show it to you on this triangle here, we have a little bit different triangle. This is more of a scalene style triangle. And this is this demonstration is that, as you see over here in the first one, like I said, it doesn't mean that it meets at a 90-degree angle. Okay, it just so happens that if this were a isosceles triangle and identified that the two sides over here, the two, side BA and BC, if I say it's an isosceles and I say those two are congruent, okay, then yes, then that would make this meet at a 90-degree angle. But I haven't given that as conditions. I haven't said, given this is an isosceles triangle, okay? So that's why we can't say it's a perpendicular bisector automatically, because as you see over here, it's definitely not going to be perpendicular to the base. All right, so here I've identified, or I'm giving you that point M at the base of the triangle here is the midpoint of side YZ. All right, so point M is the midpoint of line segment or side YZ. Okay, so that's given. All right, so now I know that it's the midpoint, right? Which also means I can say this, that the distance from M to Z is congruent to the distance from M to Y, right? So YM is congruent to MZ. Could have done that in my first triangle over here. I could say this, that one is congruent to that one, right? Okay, all right, there. So now, again, an angle bisector will cut this into 2 perfect halves, but it's going to be the angle opposite that side's midpoint. So we go up to angle X, all right, and identify line segment XM as the angle bisector, and that is connecting point X to point M. So line segment XM is my angle bisector, and that means it cuts this angle into 2 perfect halves. So this angle is congruent to this angle. Angle YXM is congruent to angle ZXM. Okay, due by the definition of what an angle bisector is. It cuts the angle, it bisects the angle, it cuts the angle into two perfect halves. Again, as you can see here, this is why I can't say that it comes down at a 90-degree angle, because it definitely doesn't. Okay, it does not, even though it looks like it did in this one over here, it doesn't every time. So by definition, an angle bisector cuts a vertex angle into two halves and connects to the midpoint of the opposite side. Okay, all right, so that's angle bisector. You need to be able to use that in some of these triangle proofs and as far as identifying what it is. All right, third here and lastly is a triangle midsegment. So let's speak here for a moment about what a triangle midsegment is. All right, kind of on theme here with the midpoint thing, except now instead of worrying about an angle, we're going to worry about, instead of connecting an angle vertex point to a single midpoint, we're going to connect two midpoints. So if I take two sides of a triangle, and it doesn't matter what kind of triangle, okay, it doesn't have to be isosceles, it doesn't have to be scalene or equilateral, whatever, any triangle, and I identify the midpoints of two sides. All right, so let's just say here point M and P are midpoints, okay, of their respective sides. Okay, so that's kind of like our given that point M and point P are midpoints. That's why I choose M and P for midpoint. All right, the line segment that connects those two midpoints is called a triangle midsegment. Okay, so what does that mean? Two big things. First of all, and this isn't part of being a midsegment, but since M and P are midpoints, that means on their own side, we can say that this is congruent to this because it's the middle of the line segment, right? So BM is congruent to MA because M is the center. It's a midpoint. Same thing over here. AP is congruent to PC, right? Due to the fact that P is the midpoint of that side. Okay. Now, but what about the triangle midsegment line itself? Here's the triangle midsegment. It's the connection of the two midpoints, and it has two important things. First of all, line segment MP, when you connect the two midpoints of two sides of a triangle, that automatically makes it, that line segment, parallel to the third side, or to, it looks like the base. It doesn't always have to be called the base, but it's the third side. So that means line segment MP is parallel to, so we have our symbolism here, or how we write things. Line segment MP is parallel to line segment BC, meaning that if they were to continue endlessly to the left or right, or negative or positive infinity, they would never intersect. Okay. Now, also meaning that any distance from line M down to line, MP down to line BC is equal, no matter where you choose as far as it comes down perpendicularly. Okay. All right. Second thing, so MP is parallel to BC. The other thing is that MP, the distance or the length of side MP, is equal to 1/2 the distance or length of BC. So it's half the length of BC. Okay? Or you could write it like this. MP is equal to BC divided by 2. Okay? Okay. Or you could do, say, 2 times MP is equal to line segment BC, right? It all just means that BC is twice as long as MP. Okay? Now, so if I were to tell you that side BC is 10 units long, that would automatically make MP 5 units long. Okay? All right, so go over here. Triangle mid-segment looks a little different in some other triangles, but it's no different. This one here is just drawn upside down. Basically, we have a triangle. Like it seems like we're always drawing triangles with a base and we work up, but sometimes the base is the top and it comes down to a vertex point. Side M and P are right here. So my triangle mid-segment, again, identifying that point M and P are midpoint. So given that they have to tell you point M and point P are midpoints, or they would have to illustrate it, meaning that they might not say anything at all. They might not say point M is a midpoint and point P is a midpoint, but if they do this and they give you the congruent marks, okay, then that illustrates that M and P are midpoints, and you have the information you need to move forward. Because if I see this, I know that XM is equal to MZ, which means point M is a midpoint, and YP is congruent to PZ, which means P is a midpoint. All right, so again, knowing that, when I connect M to P, that's my triangle mid-segment, okay? And based on, again, the triangle mid-segment, definition of a triangle mid-segment, I know now that MP is parallel to XY, and I know that MP is half as long as XY. Now, it might not look as perfect in my picture, but it is. So if I take MP, the length of MP is equal to 1/2 the length of XY. Okay? Now, again, it's not just understanding that, but it's also being able to apply it and use it. So if I give you a specific piece of information like, hey, MP is 3 units, how long is XY? Okay, or you know, if you're given that you have 2 midpoints, what can you tell me about the triangle mid-segment and its length if XY is 8? Okay. All right, now, again, these things are just, these topics that I pointed out are just to be supplementary or helpful additions to the main notes in Edmentum. Make sure you're looking over those as far as the proof, you know, the structure of a proof and how to find and fill out the missing parts of a proof, okay? But this is information that'll be helpful. Again, if you ever need any help, make sure you text, call, or you can email me. You have my information, and I'll be waiting, okay? All right, good luck.